Hello everyone, Bobbun here. You are watching episode 15 of my Factorio C block playthrough. And there's a lot to show in this episode. This is going to be an interesting one. We're going to be talking about Angel's Bioprocessing Agriculture, which is new to me because it's actually new to the 0.16 version. And I haven't played with it before. It's interesting, and it's going to solve a significant problem for us. It's definitely going to be very helpful. First, let's take a look at research. We just finished bullet shooting speed 3, so we need to pick something new off the list. And I think what I want to go for is, how about slag processing 2? This will get us the ability to do ceramic filtering and handling crystal slurry, and we'll be able to make crotinium and givelite, however you pronounce those, as well as potentially some upgraded filtration units, although these require materials that are still a bit in the future. Okay, so we'll start that one. Between episodes, I did finish a lot of science because I've got red and green science automated now, and it was very easy to do. It turns out I was thinking my metals were not going to hold up because I just have not expanded them very much, but they held up pretty well. I haven't had any shortfalls on any materials at all, and I finished a lot of science. I actually doubled the number of labs again. There are 4 labs now, but we finished, I'll just read off a list. It's a long list. Solar power was already in progress at the end of the last episode. We finished Turrets 2, Temperate Farming, Temperate Farm Upgrade, Swamp Farming, Bullet Damage 2, Bullet Shooting Speed 2, Concrete, Chemical Plant, Bullet Shooting Speed 3, Plant Pressing, Nutrient Paste, Military 2, Geode Processing 1, Geode Processing 2, Tool Belt, Advanced Material Processing, Oil Burning, and Logistics 2. And we'll definitely see where some of those technologies are being used today. I also built 5 more steam engines, and I've added 4 more electrolyzers. We are definitely getting more stuff going through. Power has been holding up just fine. This actually shows that we're running around 10 megawatts right now. I think I've seen it peak as high as about 14. So I'd love to see that we're doing a gigawatt base. We're not quite there yet. We'll see. I think that is more doable than it has previously appeared. Okay, so these farms that are on the screen right now, these machines anyway, are seed extractors. And the 2 of them up at the top that are actually doing things are trying to duplicate temperate gardens. This uses fertilizer and a temperate garden for an input, and it produces exploration tokens, and has a possibility of producing an extra garden, and the possibility is very small, about 5%, and this recipe runs for 5 minutes, 300 seconds, except that the machine is slow. It's only running at 3/4 on crafting speed, so it actually takes about 7 minutes or so to run through a whole cycle. It's definitely a very slow process duplicating these gardens because there's only a 1 in 20 chance that it will do it running 7 minutes. You figure that out. It's well over an hour to reproduce a garden. So if you want a lot of gardens, you're going to need a lot of these machines. Turns out you don't really need a lot of gardens. So that's what the ones at the top are doing. The ones at the bottom, I'm about to do some seed extraction. I've got all of my seeds from desert gardens, so I don't really need that anymore. I don't need to process any of those. But I don't have any of them from temperate or swamp gardens yet, and I don't have any swamp gardens. I've done a lot more exploring, but I just haven't found any swamp gardens yet. So I'm going to take some of my temperate gardens here, and I'm going to put them in this one, which is doing seed extraction. There are multiple recipes here for that. This is a seed extraction that has a chance of producing these exploration tokens. We'll look at those in just a minute. This one is the one I want. It produces more seeds but has no chance of producing exploration tokens. You can also say, I don't want any seeds, I just want the tokens, and you can go and try and do the garden cultivation in order to get more gardens. You can do that for each of the 3 different types here. We've got all the research done on this, so we can definitely do the same sort of thing for each of the different gardens. They produce different types of seeds, and we'll talk a little bit about the different crops that can be produced, not in great detail for much. I haven't explored all of them yet. There's a lot of stuff to go through on that, but let's go ahead and pick this one right here to do seed extraction and start getting some temperate seeds, because I don't have any and I want some. Okay, so that's these machines and this process of dealing with the gardens and getting your initial seeds. So what do you do with the seeds? Well, as you might expect, you grow crops with them, and I have a big elaborate setup over here for testing for doing just that. Now, you don't need all of this to operate the gardens. All this chemical stuff up here is for producing fertilizer, and it's a little bit elaborate. Let me fire it up here. It's short on compost at the moment. So if we put that in there, it's going to start going through all this stuff. Compost requires, or fertilizer requires compost and urea gas. So most of this is dedicated to producing urea. So we have urea coming out of this plant. It produces urea and purified water. The purified water at this point is just getting clarified. The inputs on this are ammonia and carbon dioxide. Carbon dioxide I'm just producing locally using this liquefier from wood pellets. It looks like I'm out of wood pellets here, and I don't have any in my inventory, so I can't start it back up. That's fine, no big deal. The ammonia is coming from this chemical plant, which uses a red metal catalyst and hydrogen and nitrogen to make ammonia. So we've got hydrogen coming in off the bus, we've got nitrogen coming over here from another chemical plant, and we've got a system here that is cycling our red metal catalyst, which requires copper ore and iron ore as input. And this is a process a lot like the filters. The nitrogen just comes from air separation. We get compressed air in here, and we produce nitrogen and oxygen, and I'm flaring off the oxygen, and the compressed air comes from this big thing right here, which I sort of think of as a wheezewort. If you've ever played Oxygen Not Included, you will know what that is. But this is a big machine here that sort of breathes as it goes through, which is kind of funny looking. Anyway, all of that is the apparatus for producing fertilizer, and fertilizer is an input into several processes. It was in the garden cultivation for multiplying the gardens that we just looked at. Okay, slag processing done. Let's look at, do I want the metal sorting here? Probably. This will allow us to upgrade our sorting machines. They're not running anywhere close to capacity, so they don't need upgrading. I'll tell you what, let's look instead at water treatment 3, because I think I'm probably going to start needing some saline sometime soon in bigger quantities. We'll see. It will also let us upgrade our hydro plants, although we're not quite up to where we need to be on materials for that. Is that really what I want? No, I think first I want circuit network. I want to be able to make circuits to do better control on some of these machines. Okay, this is an example of a crop field. This one is the one with the desert upgrade. There are two different crop fields. Well, there are two different flavors of crop fields. There's the default one, which if I can find it here, I don't have the materials on me to build one. It's called the basic farm, and then the basic farm can be upgraded to a temperate version, a desert version, and a swamp version. And what I found on these is that the basic farm can grow any of the crops. It grows them at 50% crafting speed. The temperate upgrade can only grow temperate crops. The desert one can only grow desert crops, and the swamp one can only grow swamp crops. They run at full crafting speed. And if you look at the energy consumption on them, it's the same across the board. So I don't, well, let's see, energy consumption 100 kilowatts, and yeah, 100 kilowatts. That doesn't seem right. This one says energy consumption 200 kilowatts. I guess because it's running at twice the speed? I don't know. What I actually found was that it doesn't look like there's any sort of efficiency gain on them. By upgrading, you're just getting a speed gain. This one's producing a crop called Zelo squash that produces these pumpkin things. And What I'm really doing here is not so much trying to produce a bunch of Zelo squash. This is just sort of an experimental setup, but it's also being used to try and multiply the seeds. Each of the different themes, and we're going to look specifically at the desert one, each of them has 5 different crops associated with them. And each crop behaves just a little bit differently in various ways. The Zelo squash, for example, requires fertilizer. There are crops that do require fertilizer and crops that don't require fertilizer. All of the crops for the desert ones do require sand, so they all require some sort of substrate. For the desert one, it's sand. For the temperate ones, it's soil. And for the swamp ones, it's mud. I think that probably makes the swamp crops maybe the best ones in terms of resource consumption because they use up mud. But unless you want the things that the swamps are specifically producing, it doesn't look like they're the best for most purposes because they don't seem to have quite the same productivity. I haven't really crunched all the numbers on everything, but that is my impression so far. Okay, so there are also 2 different seed production modes associated with crops. That's one of the key behaviors on them. For each of the 5 crops for a given theme, let's go back over here to where I've got the seeds. There are 5 different seeds and 2 different seed behaviors. One seed behavior, and for desert that covers benafran and prime dandelion, is you grow the crop, you get the harvest, and then you have to take some of the harvest that you got and convert it back into seeds. The seeds are consumed, so you basically start with 5 seeds and you run it through the cycle and you get crop out, and you have to take some of your crop and convert it back into seeds to complete the cycle. Let's take a look at that. So if we come over here to benafran, which is one of them, to produce benafran, let's see, we're going to need sand and benafran seed and water. So 5 seeds go in and 30 to 40 benafran comes out. Let's call it 35. It's a random amount. It should, over a long enough period of time, assuming that the distribution is symmetric, give you 35. We get this benafran out, and we can either convert it into beans, which is our product of interest actually. We can convert beans into things like oil and pulp, and it becomes our feedstock for whatever process we're using beans for. Or we can convert it into seeds. And you're going to get an average of, let's say, 5.5 seeds out of 10 benafran, and you're going to need 5 in order to continue the process. So you're, on average, it looks like going to use about 9 of your crop in order to get your seeds back. So your effective yield, instead of being 35, is like 26 with benafran. And the same sort of seed mechanism also holds for prime dandelion, which uses the same general sort of mechanism. Sand, 5 seeds, water, gets your crop out. It's 35. They're all 35 basically over the long term. This one produces corn, or it produces more seeds at the same rate. So that is one of the seed mechanisms. The other seed mechanism is more complicated, and it's what's being used with Zelo squash over here. So let's go ahead and look at that. Here, we're putting the Zelo squash into the field, and it looks like something isn't quite right. Let's see. Is it missing something? Because it doesn't appear to be running. We've got seeds, fertilizer, sand. We don't have enough sand. So we ran out of sand here, and it's not working. That'll be fine. We're not concerned about that at the moment. I'll fix it later. So this one is going to produce 35 of the Zelo squash, which is the crop we would expect, but it's going to convert our 5 seeds into 5 dormant seeds. The dormant seeds have to be pulled out, and they go through processing in a seed extractor, and you get 5 regular seeds back. This is very fast. This is not one of the slow things like the other one. This happens in a half a second, and there is a 5% chance of getting an extra seed. So with this mechanism, we can basically cycle the seeds out and back in to grow another crop. We get to keep the full crop, We don't have to divert any of it into seed production, but we're only gaining new seeds very slowly. We don't have control over our seed production process, so we only pick up new seeds just really slowly. And when you look at the different crops for the desert upgrade, that is the mechanism used for 3 of the crops. It's for these nilaubergine or whatever. I'll get the pronunciation wrong on these if they even have a real pronunciation. Zelo squash and arumbophylla. So it looks like we have gotten some temperate seeds. We've gotten quinoa and tiantan and wheaten. So we're getting some temperate seeds out of this process very slowly. This is one of those 5-minute things. So we have our different crops. So what can we do with the crops? Well, if you look at this Zelo squash as an example, some of these things are a little hard to look up directly in NEI because they just don't show up if you do a search. But I think we can probably get this one by going through the seed for sure. We process this and we get fruits and cellulose fiber. So the actual amounts are 3.5 times this. So we're getting, let's see, 3.5 times 6, that's 21. So we're going to average 21 fruits, and we're going to average, looks like 24.5 cellulose fiber from one crop out of this field. And these cellulose fiber we know what to do with. That goes through our whole production cycle for fuel that we're currently using. But if we go to fruits, we can see that fruits can be processed into either nutrient pulp or fermentation base. Nutrient pulp can become fuel oil, acetone gas, and synthesis gas, or it can become fuel oil and glycerol gas, or it can become acetone, ethanol, and butane. I guess we can also throw it in a barrel. The other possibility there was to produce it into fermentation base. Fermentation base can become compost and ethanol. I think ethanol is going to be used for plastic, or we can turn it into compost and acetic acid, which I think is also used for plastic. Let's see, acetic acid, it can become acetic anhydride. It can become cellulose acetate mixture, that is definitely for plastic. Or it can become liquid plastic in conjunction with cellulose fiber, acetic acid, and we need propionic acid, which would be something we need to produce that we haven't done yet. I'm not sure where that comes from. Ethylene, carbon monoxide, and purified water, so that's maybe not too bad. Ethylene is a little more common. It's from ethane, and ethane is from natural gas. Okay, so it's a way to produce plastic if you follow through on that. One of them was producing fuel oil. That's the one that I'm most interested in the short term, but you can see that we've got quite a bit of it here. This stuff is pretty productive because it's running 35 for every cycle, and the cycle is lasting 60 seconds. So every minute it's producing 35 of these. I'll have to get some sand for that. We'll do that in a little bit. What is the bigger picture on these crops other than just producing crops? Well, that's down here where I have been spending a lot of time doing some experimentation. I needed sand as an input here, so I've got this set up with these washing plants producing sand. These are the Mark IIs. I do have the upgrade available for it. I haven't done the other plant in the Mark IIs yet, but I will. They're just faster and more efficient. These are only producing sand, and as a consequence, because my sand is backed up on a belt that you can barely see at the bottom, but we'll take a little closer look in a minute, they're not really running very much. I've got the usual sort of, the mud comes off and goes into landfill, and the hydrogen sulfide comes off and gets made into valuable sulfur here. There's that piece. This isn't really part of the crop processing, it's just dealing with the byproducts from here. So we get sand out of here, and it comes down a belt, and it goes into 4 farms that I've got set up. These are producing nilaubergine, which does not require fertilizer, it just requires sand and water and seeds. It does use this seed cycle where we have to break dormancy on the seeds, so I'm very slowly accumulating more seeds. But I have gotten enough now to run 4 farms, and if I were to go and gather all my extras in here, I could probably do another 1, maybe 2. So these produce crops. The crops come out on the belts. I've got 4 of these things right now doing the seed cycling. Because it's so fast, you don't really need 4 of them to cycle the seeds. One of these could cycle seeds for probably over 100 farms for sure. The problem is, if you just put them on a belt, you're going to have a hard time until you've got a lot of seeds accumulated actually getting the 5 into the farm that you need and running your farms at optimal efficiency. So for the moment, I've just got 1 per, and eventually I will use a belt to run them through and do it. Rather than risk having them accumulate at the end of the belt, this might actually be an application for something I wouldn't normally recommend at all, but a belt that goes in a loop, so that if it goes around, it can come back through and revisit the same ones, so that your extra seeds can just sort of float around on the loop. Eventually the belt would fill up and you'd have to do something with it, but at least for a long time, until the belt filled up, you would be in good shape there and could distribute the seeds more evenly. Essentially, each one would get twice as many seeds as it needed due to the way inserters pick things up in stock machines, which is much better than having them sit off at the end of the belt where only the last machine in line can ever look at it again. Okay, well, these are producing lots of nil aubergines. Basically, it looks like some sort of gourd that goes down the line here, and it's going into a chest. I'm accumulating quite a bit of them at this point because I do not have, this is just a test setup and I don't have the machine set up for what I need. But what I'm doing with the nil aubergines is I'm converting them into pips and crystal dust. And for now, the crystal dust is just going over here. Crystal dust is part of geode processing, which I have researched because I'm going to need to use it to get more materials. And I'll probably do an experimental setup with that quite soon. But for now, I'm just throwing that into a warehouse. It's not producing very much crystal dust, but it's been running for a while, so it has accumulated some. The other product is the pips, and the pips are what's kind of interesting here. I am gradually processing the pips. The pips go into this machine called a press, which is converting them into raw vegetable oil. And the raw vegetable oil is going through charcoal filtering in this machine. You can also do ceramic filtering with it. I don't have any ceramic filtering because I haven't started aluminum processing. The yields are a little bit different based on which ones you get. You get a higher oil yield from the ceramic, but you get a lower pulp yield. Basically, this produces, it takes purified water and raw vegetable oil and produces vegetable oil and pulp. The vegetable oil is going through, both of these are getting processed here. The vegetable oil is going through just a regular oil refinery, and it's getting split into fuel oil and mineral oil. And the mineral oil is going into, these are just going into tanks at the moment. So I've accumulated 44,000 base mineral oil that I can't use right now because I don't have anything set up to use mineral oil. And I've accumulated a lot more fuel oil. I'm up to 110,000, 116,000. And that is getting close to the capacity of this tank. That's a lot of fuel oil. The pulp is coming out, and it's going into a gas refinery, and it's getting converted into more fuel oil and glycerol. Basically, the pulp is sort of the waste of this filtration process, but it can be used to extract more oil, and it can also produce this glycerol gas. There are a couple of other recipes with it. The glycerol gas I picked because I didn't want some of the other side products. I don't want the glycerol gas either right now. I can't do anything with it. I've got 14,000. It's used eventually in explosives manufacture, but most likely it will all just get flared at some point. So if we continue down, here's my fuel oil. So what do you do with fuel oil? Well, there are 2 things I can do with it right now. One of them is I could use it to upgrade charcoal to solid fuel. And that's a really good process for upgrading your solid fuel or upgrading your charcoal. It's much better than the pelleting that we're doing right now. The fuel yield on that is enormous. It basically takes 1 piece of charcoal and it will upgraded into 2 solid fuels. So the charcoal has a value of 5 megajoules. The solid fuel comes out at 25 megajoules and you get 2, so you're getting 50 megajoules. So yeah, you're adding a great deal there. So I'm probably going to set some of that up. But let's look at the other use first. The other use is to run these generators right here. This machine is an oil boiler. It's from KS Power. It comes from the oil burning research that I did between episodes. And this, everything is set up as a crafting recipe in it. It's producing 90 steam from water and fuel oil. The fuel oil it uses 3 of. So if we look at these steam engines, these are just the default ones. It produces it at a temperature of 165 degrees, by the way, which is what these vanilla steam engines use. So with this, we're probably just using the vanilla steam engines, not the Bob's versions. But this consumes 30 steam per second and produces 900 kilowatts of power. Efficiency doesn't play a role on this, I don't believe. I think all of the efficiency losses are on the boiler stage when you're looking at power production. And it doesn't even apply to this because it's just doing a crafting recipe. So looking at that, that means that 3 fuel produces enough steam to run 3 of these engines for 1 second. So 1 fuel will run 1 of these for 1 second, which means that 1 fuel contains 900 kilojoules of energy. If you were to go back to the solid fuel calculation and crunch the numbers, and I did, it looks like that's been taken into account on the solid fuel production because it actually upgrades by that exact amount when you look at how it works. The difference is when you burn the solid fuel, you're going to have to deal with efficiency on the boiler and you're going to get less fuel value out of it. So this turns out to be a better way for generating electricity than going ahead and converting this into solid fuel. So I'm probably going to be setting these up. One of the things I did not mention at the beginning of this examination is that these engines that are running here are not providing any power to the base, but they are running all of this apparatus here, all of this production associated with this experimental setup. They're not hooked up to the main power anywhere. They're not running these labs, but they're running all of this, and it's running at a tiny fraction of its capacity, and this tank is filling up so fast. It's almost full, and it's about to be full, at which point all this processing will start to back up. So I'm going to have to do something with all that fuel, and it's going to run the base. That's essentially what's going to happen. Is I'm going to take and convert this over. This is an experimental setup. I'm going to have to move it all at some point. I think I probably will convert all of this to solid fuel, not for running generators, but for running all of the other machines like the smelters and so on. So I am going to probably convert all that to solid fuel. It's more storable as solid fuel. You can store a lot more energy that way. The other thing to look at is, remember, we computed that 1 drop of this fuel, or 1 unit of it, I'm just going to call it a drop, it is worth 900 kilojoules. This refinery is running continuously and producing 70 drops each time it runs through, which means that the energy equivalent output of this oil refinery from these 4 farms, and it's not even keeping up, we're generating excess here, is 63 megawatts, which is like 5 times as much power as this whole base is using from these 4 farms. So I think this is going to be our energy production. I think this will probably scale up all the way into the gigawatt range without any real trouble. I probably don't have enough space right now to do that, but I would need a whole lot more space to use a gigawatt of power anyway. So I think this is probably going to be our power production solution as soon as I get it out of this experimental setup into something real and get it balanced a little better so that we make good use of the materials. This is going to be our power production all the way until we convert over to nuclear, I imagine. So that's going to solve a lot of problems going down the road. And that's probably the huge value in this mod pack of going through and doing the Angel's crops, is the energy production is absolutely huge. It is going to need input of charcoal unless I go and convert to ceramic filtering. I'm probably going to do that pretty soon. One of the things that's going to be on my agenda coming up is more metals production and a greater diversity of metals production. In keeping with that idea, let's look at another technology here. Let's go for hydro refining. This will allow us to convert our crushed ores into ore chunks, I think they're called. And that's going to get us some geodes and some wastewater out. The wastewater is going to get us some mineralized and some other materials. And the chunks, when they're sorted, give a greater diversity of materials. This one, for example, here it looks like we're getting some maybe aluminum and gold out of our rubite. I mean, it cuts down on production of things like iron, but it will get us a greater diversity of metals. And right now, we're needing that diversity. We can make up the iron just by scaling up production, I think. There are also other mechanisms to get iron more directly, and we'll have to look at that as well. So that's going to be for between episodes, is looking at what I can do to improve my metals and metal diversity. Probably get all this fuel, and we've just in the little bit since I last looked at it, we've gained another 2,000 fuel oil there. Get all that fuel mostly converted into solid fuel. Start converting this belt with the pellets over into solid fuel. Set up a new power plant to replace this one down here. You can see I'm running 15 engines right now. These are going nowhere near capacity. This is still going nowhere near capacity. I'm really just not using that much energy, so I haven't had to go and expand algae farms to crazy amounts, and we're probably not even going to expand them. If we need more charcoal, and we probably will, then this is going to get devoted probably to charcoal production, and the charcoal will be upgraded to solid fuel until we fill a silo with it. But otherwise, I think we're probably going to run the base on the liquid fuel, because that looks like a much better option over the long term. The other thing to look at, of course, will be more metals production. You can see I've got more electrolyzers over here. I'm up to 14 of them right now, and my slag line is actually backlogged, even doing research with 4 labs, so probably expand labs or something. I don't know. There are going to be a few other things. Let's look at, I didn't start my hydro refining. We'll go ahead and start that. And that's sort of what's going on. It looks like we're really going to be starting to ramp up the possibility of power production. I just have to find something to do with it. That's going to be geode processing and more extensive ore processing, so that we can get more metals coming through here, because right now our new techs are going to require more metals, and we're just not producing them right now. So anyway, thank you for watching. I'll see you next time.